Hello and very welcome everyone to this session of the World Geography Part 2. In today's session, we are going to discuss the things that can be asked in the exams and that will be helpful for your preparation. So let's start. So before we start, the images, text and other materials used in our presentations are for educational purpose only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the same. So first we need to discuss is about the solar system. So our solar system consists of the sun, 8 major planets, dwarf planets like Pluto, Ceres and Eris, etc. Satellites and countless minor planets, asteroids, meteors, comets and debris. The mass of the solar system, near about 99.85%, is contained within the sun. So these are the two very important points. So solar system consists of the major planets, the 8 planets, the meteors, the asteroids, the satellites, and other than that, the dwarf planets. And apart from that, the comets and debris all are the part of the solar system. And in the center, we have the sun. Then the solar system, in the solar system, 99.85% of the mass is consist only in sun. Now the sun, let's talk about it. So the sun is a distance of 27,000 light years from the center of our galaxy Milky Way. Light year is equal to 9.46 into 10 raised to the power 12 kilometer. Remember that. And located in one of the spiral arms of it. In 230 million years, the sun revolves around once to the center of the galaxy. This time period is known as the cosmos years. So as the earth rotates around the sun, the earth revolves around the sun also revolves around the center of the galaxy, and for that purpose it takes 230 million years, and that particular time is known as the cosmos years. The distance between the sun and the earth is on average 150 million kilometers, and the light coming from the sun takes 8 minutes and 20 seconds to reach the earth. So as we know, the distance is also known as the astronomical unit, and we know the speed of light. So if we do a little mathematics, so we will get the answer that it takes 8 minutes and 20 seconds for the light to reach the earth. The diameter of the sun is 13,91,191,016 kilometer, and its age is about 4.6 billion years. The age of the universe is about 13.8 billion years according to Big Bang theory, and the sun was formed around 4.6 billion years, and the earth is formed around 4.5 billion years ago. At its axis, the sun completes a single rotation in about 27 days. Now let's talk about some chemical compositions of the sun. In that, hydrogen consists of 71% of the total chemical composition. Helium consists of 26.5%, and other gases comes 2.5%. Nuclear fusion is the main source of enormous energy of the sun. 4 hydrogen nuclei fuse to form a helium nucleus in this process of fusion. Nuclear fusion is the process in which the hydrogen isotopes merge together and creates the helium. So the process of nuclear fusion creates hydrogen transfer hydrogen into helium or transform hydrogen into helium, and that is how the energy on sun forms. And this formation of energy creates the light and also the energy that helps us in lot of different type of cores on earth. Now let's talk about the structure of the sun. First thing is core. Core is the center region of the sun, and it forms 25% of the radius of the sun. The temperature of the core is 1 crore 50 lakh degrees Celsius, that is approximately 1.5 crore degrees Celsius. Now let's talk about some other layers like photosphere. Photosphere is the visible surface of the sun. The temperature of the photosphere surface is approximately 5500 degrees Celsius. And do remember that photosphere is the layer of sun that is visible to the naked eyes. If you go outside and just look at the sun, you will find a white surface, and that white surface is the photosphere. Then comes the chromosphere, the surface which is present above till 400 to 2100 kilometers, the photosphere. Above 23,000 Kelvin, the chromosphere consists of ionized hydrogen and helium atoms. So these are the top layers of the sun. Then comes the corona. The corona is the outermost part of the sun's atmosphere, visible during the time of full solar eclipse. Corona is that layer of sun which is visible during the full solar eclipse, and corona is also the layer to which the recent NASA mission of a probe mission, that is basically known as the Parker mission, reached. That is the closest we have ever reached to the sun. That is the corona. Corona is a region of highly refined and hot gases which spreads millions of kilometers in space. It is a distinctive atmosphere of plasma that surrounds the sun and other celestial bodies. Sunspots. Sunspot is a dark patch on the surface of the sun. Sunspots are relatively about 500 to 1500 degrees Celsius cooler than the surrounding chromosphere, so it appears as a dark spot. The darker surface is known as umbra, and that region which is surrounded by a slightly less dark area is known as penumbra. Now let's talk about very important point, solar wind. The solar wind flows outwards from the sun at a speed of 900 km per second and at a temperature of 1 million degrees Celsius. It is made of ionized atoms called plasma. Effects of solar wind is called aurora. So the solar winds are ionized particles that flows out from the sun, and as soon as it comes in contact with the magnetic field of the earth and with the ionosphere, they creates the lights that are famously known as the aurora in the north pole and the south pole. And in the north pole they are known as aurora borealis, and in south pole they are known as aurora australis, and northern light and southern lights also. Now let's talk about the bodies of the solar system, in which we are going to discuss about the planets. So planets, if we discuss, are like Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. So this is the chronology of these planets with respect to the distance from the sun. So this is the chronology in which they are found in the solar system. Then dwarf planets are also there, which are Pluto, Ceres, Haumea, Eris and some others also. And minor bodies like satellites, meteors, comets, asteroids, etc. Dwarf planets were basically those planets which are large enough to be called as planets but cannot be called as planets because when they orbit around the sun, they intersect with the orbiting length of the other planets. Like Pluto, when orbiting around the sun, it bisects the orbit of the Neptune. That is why it is not termed as planet but as dwarf planet. All the planets are celestial bodies which revolves around a sun or star is known as a planet. According to their characteristics, the planet of our solar system can be divisible in two groups. Inner planets, the planets which are made up of rock and metals, and they have relatively high density as they lie between the sun and the belts of asteroids. So that are called the inner planets. The inner circle consists of 4 planets: Mercury, Venus, Earth or Mars. Then comes the outer planets: Jupiter, Saturn, Uranus, Neptune, and the dwarf planet Pluto are known as outer planets. They mainly consist of gas, so the 4 outer planets are called the gas giants. So remember one more thing, that inner planets are also known as terrestrial planets because they are all solid planets, and outer planets are also known as Jovian planets or gaseous planets. The outer planets are composed mainly of hydrogen and helium, which lack a solid surface, but their moons are solid. Planets in increasing order according to their distance from the Sun. First is Mercury, then Venus, then Earth, then Mars, Jupiter, Saturn, Uranus, and Neptune. So these are the 8 planets, and this is the chronology of these 8 planets according to the distance from the Sun. Here you can see this also in this diagram or photo. You can see all these planets are present in the according to the distance from the Sun. Now, according to the size from large to small, the first one is the Jupiter, that is the largest planet of our solar system. Then comes the Saturn, then Uranus, and then Neptune. So that means the way it is there from the distance from the Sun, the Jupiter, Saturn, Uranus, and Neptune. Similarly, you can put them again while you are arranging them in the size. So Jupiter, Saturn, Uranus, and Neptune. Then on the 5th position, always remember, comes the Earth. Venus is also known as the twin sister of Earth, that is why on 6th position. Then Mars, and last is Mercury, that we all know is the smallest planet. Do remember that out of all these planets, Earth is the highest dense planet, and after that, if we talk about the least dense planet, that is Saturn. Now let's talk about them one by one. So first is Mercury. So Mercury is also called the god of commerce and skills, and sometimes also known as the god of wisdom and intelligence. It is the nearest planet to the Sun and also the smallest one. Mercury has no atmosphere to retain heat, so its day temperature is about 430 degrees Celsius and night temperature falls below minus 170 degrees Celsius. As we all know that it has no atmosphere, and that is why it cannot retain the coming sun rays. So that is why in day the temperature is around 430 degrees Celsius, and at night it would be around minus 170 degrees Celsius, and that is why we cannot call Mercury as the hottest planet. So Mercury revolves around the Sun in only 88 days, and its rotational period is 59 days. On the surface of Mercury, there are many craters. Calories Basin crater is the biggest among them, with a diameter of 1300 km. So that is Mercury. Then let's talk about the Venus. Venus is also known as the Veiled planet, goddess Venus of beauty. It is similar to the Earth in size, mass, and density. So it is considered as Earth's twin. Venus is the third brightest object visible from Earth after the Sun and the Moon. Just before the sunrise, it is clearly visible, so it is also known as the morning star. Venus is also visible immediately after sunset in the evening, so it is also known as the evening star. And also remember, it is also the brightest planet and the morning and evening star. And about it, one more thing that you can remember, that it is the twin sister of Earth. Venus rotates very slowly, and it takes 243 Earth days to complete one rotation. So remember, it is the slowest rotating planet as well. It rotates in the opposite direction, that is clockwise, or that is from east to west to most other planets. So majorly all the planets rotates from west to east, and that is the anti-clockwise direction. But only two planets we have that rotates in the clockwise direction. One is the Venus that rotates from east to west, and another one is the Uranus that rotates from north to south. Why from north to south? Because it is also a laying planet. It is tilted by around 98 degree on its axis. To complete a revolution around the Sun, it takes 224.7 Earth days. The highest place on Venus is Maxwell Montes, which is nearly 800 km wide and 11 km high. The highest plateau of Venus is Star Terra. So do remember all these things related to the Venus. Let's talk about Earth. Earth is also known as the blue planet. Earth is the fifth largest planet of the solar system and is the only planet where life exists. It is located in the life-favored ecosphere of the Sun. The Earth's atmosphere is very dense and contains enough oxygen and water vapor. It is called blue planet because it has the largest and most continuous oceans in our solar system. In 23 hours, 56 minutes and 4.1 seconds, it completes one rotation and is inclined at an angle of 23.5 degrees. Stars appear as rotating along concentric circular paths when they are observed from one of the poles of the Earth. The celestial pole is the imaginary center of such circular paths. So do remember all these things, and we will also discuss about the Earth in detail later on. Now let's talk about the satellites of the Earth. So Moon is the only satellite of the Earth. Moon. Selenology is a scientific study of the Moon. Remember that. Moon is about 3,84,400 km away from us, that is the Earth. Light takes only a second to reach us from the Moon. It revolves around once to the Earth in 27 days, 7 hours, 43 minutes, and also rotates on its own axis in the same period of time. Hence, only one side of the Moon is visible to us on the Earth. On 20 July 1969, Neil Armstrong was the first and Buzz Aldrin was the second who stepped on the surface of the Moon under the Apollo 11 mission that was launched by NASA. Mons Huygens, 18046 feet, is the highest mountain on the Moon. Largest basin on the Moon are the South Pole Aitken SPA Basin. Recently, the Chandrayaan-3 mission, which reached the south pole of the Moon and became the first successful mission to reach the South Pole of the Moon, and that was sent by ISRO. And remember that they reached in 2023. Apart from that, remember all these points related to the Moon, and let's move further. Now let's talk about the Mars. Before I discuss further, remember one more point, that Mercury and Venus are also two planets which do not have any satellite around them. So remember that, and all the other planets in the solar system, they have satellites, like Moon they have, but not Mercury and Venus. So Mars is also known as the red planet and the god of war. The Mars surface glows with a reddish light due to the presence of iron-rich red soil, so it is called a red planet. So remember, it is known as the god of war and anger, and also the red planet because of the presence of iron-rich red soil. Mars has only two satellites, that are Phobos and Deimos. Deimos is the smallest satellite of our solar system as well, remember that. The atmosphere of Mars consists of 95.32% carbon dioxide, 1.6% argon, 2.7% nitrogen, along with traces of oxygen and water. It rotates on its own axis once in 24 hours and 37 minutes, while it is inclined at an angle of 25 degrees to the plane of its orbit. Mars has seasons much like the Earth, since this is much similar to Earth. Remember all these things. And remember that Venus was also the planet that also has around 96% carbon dioxide in its atmosphere, and that is why Venus becomes the hottest planet in our solar system, and also termed as the pressure cooker atmosphere. Now let's talk about the largest planet, that is Jupiter. Jupiter is also known as giant planets and ruler of gods. This is the biggest planet in our solar system. Jupiter contains mostly hydrogen and helium gases. It is a huge sphere of gas. It is composed mostly of gas and liquid swirling in complex pattern with no solid surface. It takes about 11.9 terrestrial years while revolving around the Sun, and it takes only 9.9 hours for a spin about its own axis. So remember that it is the fastest rotating planet. Due to its fast rotation, it causes a swirling storm of gases that moves in a counterclockwise direction, which is known as the Great Red Spot. So always remember that Great Red Spot is found on Jupiter. It is a source of radio waves. It has as many as 95 satellites. So currently they have around discovered 95 satellites around Jupiter. In 1610, Galileo discovered its 4 big satellites known as Galilean satellites, name of its 4 big satellites, which was disordered by Galileo. And these are Io, Europa, Ganymede, Callisto. The largest satellite of Jupiter is Ganymede. The diameter is 5268 km, which is slightly bigger than Mercury. And remember that Ganymede is also the largest satellite of our solar system, where Deimos was the smallest one. Let's talk about Saturn. Saturn is also known as the ring planet and god of agriculture. It has the lowest density, 0.687 gram per centimeter cube, among the entire planets, and also the second largest planet of the solar system. Its rings are probably made up of billions of particles of ice and ice-covered rocks. It is also a gaseous planet which contains mainly hydrogen and helium gases. Saturn rotates very fast and its spin period is 10 hours 32 minutes. Saturn's satellite Titan is the second largest moon in the solar system and the only satellite with a substantial atmosphere. The total number of Saturn satellites is 146. And remember that Saturn has the largest number of satellites currently, as it has 146 satellites that are discovered so far around it. And also the second largest satellite in our solar system is Titan, that is revolve around the Saturn. And any spot of red color 6,000 km long is seen on the surface of Saturn. So all do remember that these are the things. And Saturn is also termed as the galaxy-like planet. Let's talk about Uranus. So Uranus is also known as the green planet and the god of heaven. This is because of the presence of high presence of methane gas. Uranus is the third largest planet in the solar system, which was discovered by William Herschel in 1781. Venus and Uranus have a strange retrograde rotation clockwise, that is opposite of the sun's rotation. As I was telling you earlier also, Uranus rotates in the clockwise direction, but from north to south. To complete one revolution around the sun, Uranus takes 84 years and takes 17.25 hours for one rotation about its own axis. Uranus has 27 satellites and many rings around its equatorial plane, which is formed by ice and large rocks seen around the equator. Uranus' atmosphere is very dense and its atmosphere contains hydrogen 83%, helium 15%, methane 2%. Uranus' 5 most important satellites are Titania, Oberon, Ariel, and Umbriel. And out of all of them, Titania is the largest one. So remember that Titan was the largest satellite of Saturn and Titania is the largest of Uranus. Then comes the Miranda. Now let's talk about Neptune. Neptune is also known as a twin of Uranus and the god of sea. Neptune is surrounded by a thick atmosphere of hydrogen and helium and contains a high proportion of ices such as water, ammonia, and methane ice giants. To emphasize this distinction, it was discovered by John Gottfried Galle, who used calculations by John Adams and Leverrier. In the order of distance from the Sun, Neptune is the 8th planet of the solar system. It has the strongest sustained winds, 2100 km per hour, of any planet in the solar system. Neptune has 14 satellites and 4 rings like Jupiter and Saturn. It also has an internal source of heat energy. Triton is the largest satellite of Neptune. So Titan is the largest satellite of Saturn, then Titania is the largest one of Uranus, and now Triton is the largest one of Neptune. Now let's talk about the dwarf planets. So IAU, that is International Astronomical Union definition of dwarf planet. Dwarf planet is an object that meets planetary criteria except that it has not cleared debris from its orbital neighborhood. Example, Pluto. As I was telling you earlier, that it has not cleared the debris, as well as they also bisect the orbit of other planets, like Pluto bisects the orbit of Neptune. Now let's talk about Pluto. So when it discovered in 1930, it was considered to be the 9th planet. This changed in 2006 with the adoption of a formal definition of a planet. International Astronomical Union's definition of a planet. A planet is an object that orbits the Sun, has sufficient mass to assume hydrostatic equilibrium, a nearly round shape, is not a satellite, moon of another object, and has removed debris and small objects from the area around its orbit. So if Pluto is considered a planet, then many other objects like Eris will also have to be considered as planets. Hence Pluto, diameter 2377 km, Kuiper belt. It is also found in Kuiper belt. Kuiper belt is the outer ring of our solar system, and after that comes the Oort clouds. Was voted by IAU as a dwarf planet, just like Ceres asteroid belt and Eris, diameter 2326 km, Kuiper belt. Charon is the largest moon of Pluto. Ceres 2.77 AU is the largest asteroid, 946 km in diameter, a protoplanet and a dwarf planet. Ceres has a mass large enough for its own gravity to pull it into a spherical shape. So do remember all these things. So if we talk about the planets and a dwarf planet, I hope all the points are very clear to all of you. Now let's talk about the minor bodies, asteroids. They are heavenly bodies which form between the orbits of Mars and Jupiter. Asteroids, planetoids, another term for an asteroid, are composed mainly of refractory, rocky and metallic minerals with some ice. So there was a story that there was a planet exist between Mars and Jupiter and it got exploded. Then the debris of that planet is revolving around the Sun, remaining between the Mars and Jupiter because of their gravitational pull, and that is known as the asteroid. Amos are those asteroids which meet the orbit of Mars. Apollo, those asteroids which meet the orbit of Earth. Athens, those asteroids which have orbits of radius less than that required to meet the orbit of Earth. The asteroid belt lies between 2.3 and 3.3 AU, that is astronomical unit from the Sun. I hope you remember. I told you astronomical unit means the distance between the Earth and the Sun, that is approximately 150 million kilometer. So whenever we are seeing 2.3 AU or 3.3 AU, that means 2.3 into 150 million kilometers. Largest asteroid is Ceres, that is diameter 946 kilometer. Let's talk about comets. Comets are made of frozen gases, water, ammonia, methane, and carbon dioxide, which hold together small pieces of rocky and metallic minerals. They are celestial bodies, which are chunks of ice, frozen gas, and rock particles. When comets come near to the Sun, its frozen gas vaporizes due to the solar energy and produces a glowing head called a coma. Comets start burning with a tail that can stretch a million kilometers. Its tail is always positioned away from the Sun. Some important comets. Halley's Comet, it comes after every 76 years. Shoemaker-Levy 9. Hale-Bopp meteors. But before we discuss about meteors, so I hope you are able to understand that what are comets. So comets are the revolving objects that revolves around the Sun in a particular time period. And out of them, the most famous is Halley's Comet that comes in 76 years. And they are majorly made of ice, frozen gas, and rock particles. And as soon as they come near the Sun, the gases, the white ice and other things, the frozen gases, they vaporizes. Always remember that the tail of these comets always remain away from the Sun. Let's talk about meteors now. Meteors are popularly known as shooting stars because when they are traveling at a great speed through space, which becomes luminous during entering the atmosphere at about 200 km above the Earth's surface due to heat produced by friction. In some cases, the meteoroid does not burn up completely and makes its way to the Earth's surface, but a few larger ones reach the ground and are called meteorites. So meteors are the debris that enters the Earth's atmosphere, and as soon as they enters, the time they reaches mesosphere, they burns out because mesosphere is the coldest layer, and those debris or meteors that strikes the ground are known as meteorites. Some important facts related to the planets. So here we can see this is the whole list of the number of satellites, the radius, rotation, revolution, and distance from the Sun in lakh kilometer. Like Mercury, it has 0 satellites, radius 2440 kilometer, rotation 58.6 days, revolution 87.97 days, and distance from the Sun in kilometer is 579 kilometer. Then Venus is 0, radius is 6052, and 243 days it takes to rotate, 224.7 days in revolution, 1082 kilometers is the distance, from 1082 lakh kilometers the distance. Then Earth, number of satellite 1, 6371 is the radius, 23.9 hour is the time of rotation, 365.26 days in revolution, and 1496 lakh kilometer is the distance. Mars has 2 satellites, 3390, 24.6 hours rotation, 687 days revolution, 2279 lakh kilometers the distance. Jupiter has 95 satellites, 69,911 radius kilometer is the radius, 9.9 hours in rotation, 11.9 years in revolution, and 7786 is the distance from the Sun in lakh kilometers. Saturn 146 satellite, that is the highest one, 58,232 kilometers the radius, 10.3 hours is the rotation, 29.5 years is the time taken, and 14335 lakh kilometers is the distance from the sun. Uranus, 27 satellites it has, 25,362 kilometers is the radius, 17.2 hours is the rotation, 84 years is the revolution, 28,725 lakh kilometers is the distance. Then Neptune has total 14 satellites, 24,622 radius kilometer, 16.6 hours is the rotation, and 164.8 years is the revolution. Then 44,951 is the distance from the sun in lakh kilometers. So these are some important facts related to the planets. Let's talk about the asteroid belt, an area between Mars and Jupiter where many of these rock orbits the sun is known as the asteroid belt. Kuiper belt. Kuiper belt is similar to the asteroid belt, which is circumstellar disk in the solar system beyond the planets. Kuiper belt has 3 recognized dwarf planets: Pluto, Haumea, Makemake. It consists of remnants of the solar system's formation and small bodies. So one is the asteroid belt. It is found between Mars and Jupiter, and Kuiper belt is found beyond the Pluto. Now let's talk about the rotational motion of the Earth. So here we can see that this is our Earth, and it is showing in the diagram how it rotates. You can clearly see that it rotates from west to east, and let's read more about it. So in 23 hours, 56 minutes and 4 seconds, Earth rotates on its own axis from west to east. This motion is known as the rotation of the Earth. It rotates on a tilted axis. The phenomena of day and night occurring on the Earth is due to its rotation on its axis. Circle of illumination. The circle that divides the day from night on the globe is called the circle of illumination. With the normal Earth rotational axis, it makes an angle of 23.5 degree, while with its orbit plane, it makes an angle of 66.5 degree. The plan of Earth's orbit around the sun is called the orbital plane. So I hope all these points are really clear to all of you, that what is the tilted axis of the Earth, that is around 23.5 degrees, and while its orbital plane, it makes around 66.5 degrees. And what is the rotation time? That is 23 hours, 56 minutes and 4 seconds. Now revolution motion of the Earth. So here we can see that how the Earth is revolving around the sun, and because of which the seasonal change we can also see. And always remember that seasonal change is because of two things. One is the tiltness of the Earth, and the other one is the revolution of Earth around the sun. Always remember that the impact of distance from the sun is not a factor in any kind of season change on Earth. So in 365 days, 5 hours, 48 minutes and 46 seconds, the Earth revolves around the sun in an orbit. This motion of the Earth is known as revolutionary motion. Due to this motion, the phenomena of season change occurs on the Earth. Leap year. Every year during the revolution of the sun, Earth saves 6 hours, which are added to make one day. That is 24 hours, over a span of 4 years. This surplus day is added to the month of February. Due to this addition, every 4th year, February is 29 days instead of 28 days. Such a year with 366 days is called a leap year. So as 2024 was a leap year, now the second leap year will come, next leap year will come in 2028. So remember that it is the revolution motion of the Earth. The distance between the sun and the Earth changes due to the revolution motion of the Earth. We can divide this distance into two phases. Perihelion. Perihelion is the position of the Earth where the distance between the sun and the Earth is minimum, and it is about 14.73 crore kilometer. On January 3rd every year, the distance between them is minimum due to the elliptical orbit of the Earth around the Sun. Aphelion is the position of the Earth in which the Earth is farthest from the Sun on July 4 every year. At this time, the Earth is said to be in aphelion. During aphelion, the distance between them is 15.21 crore kilometer. So do remember that perihelion is the position in which the distance between Earth and Sun is minimum, and that falls on 3rd of January. So as I was saying earlier also, the distance between the Sun and the Earth does not impact the season change, because we can see that Earth and Sun are closer in January, but we can experience winter in northern hemisphere, that is in India. So that is the perfect example of it. And aphelion, if we talk about, is the time that is called 4th of July, and this is the time and the distance between the Earth and Sun is maximum, and that falls on 4th of July. Now let's talk about the solstice. Solstice phenomena can be divided into two types: summer solstice and winter solstice. Summer solstice, the north pole of the Earth is tilted towards the Sun on 21st June. Due to this recline, the Sun is overhead at the Tropic of Cancer with an angle of 23.5 degree north. The rays of the Sun falls directly on the Tropic of Cancer. As a result, these areas receive more heat. So as we know that Earth revolves around the Sun, and while revolving it is also tilted. So there comes two positions in a year. First is 21st June, that is the summer solstice in northern hemisphere, and the sun rays or the sun is vertically above the Tropic of Cancer, because of which the days are longer and the summer is prevailing in the northern hemisphere. This day is known as summer solstice. During summer solstice period, the northern hemisphere will have its longest day and shortest night, as I was saying. Now comes the winter solstice. So the southern hemisphere of the Earth is tilted towards the Sun on 22nd December, while the Sun is vertical at the Tropic of Capricorn with an angle of 23.5 degrees south. A larger portion of the southern hemisphere of the Earth gets light, hence there is summer in the southern hemisphere with longer days and shorter nights, while the reverse happens in the northern hemisphere. This position of the Earth is called a winter solstice. So this is just vice versa of summer solstice, and in the northern hemisphere we experience winter, and on 21st of December to 22nd of December becomes the shortest day in northern hemisphere. The Sun is vertical at the equator on 21st March and 23rd September. That is why they are called equinox. During these 2 days, equal days and equal nights happens in all parts of the world. Hence, you find that there are days and nights and changes in the seasons due because of the rotation and revolution of the Earth respectively. On 21st March and 23rd September, direct rays of Sun falls on the equator. At this position, neither of the poles is tilted towards the Sun. So the whole Earth experiences equal days and equal nights. This is called an equinox. Equinox are basically of two types: spring or vernal equinox, and the other one is autumnal equinox. In the northern hemisphere, there is a spring season, while autumn season in the southern hemisphere on March 21. Hence, the day is known as the spring equinox. So we all experience spring season in the month of March, and that is also known as the spring equinox. Then comes the autumnal equinox. So on 23rd September, there is autumn season in the northern hemisphere and spring season in the southern hemisphere. Thus, the day is known as the autumnal equinox. And in northern hemisphere, we experience autumn in September, and after that comes the winter. Now let's talk about the Earth's rotation. So Earth rotation causes day and night. That is a very simple thing that we all know. Because of Earth's rotation, it causes day and night. Earth's revolution causes season change. Equinoxes. All latitudes have equal day and night, 12 hours. 21st March and 23rd September are the days that are called equinox, like vernal equinox and autumnal equinox. Duration of the day. At an angle of 66.5 degree, the axis of the Earth is tilted to the plane of the ecliptic. Due to this inclination, it gives different seasons and varying length of day and night. So as I was telling you earlier also, that because of two things and two reasons, the season change happens. One is the revolution, another one is the tiltness of Earth. During the winter season, December, when one goes northwards in the northern hemisphere, so the length of the day gradually decreases. During the midwinter of 22 December, at the Arctic Circle, angle of 66.5 degree, there is darkness for the whole day, and the sun never rises. Beyond the Arctic Circle, the number of days with complete darkness increases until one reaches North Pole, 90 degree north, when the half the year will have darkness. So that is because the Earth is tilted and it is revolving around the sun, because of which the vertical rays of sun are falling from one place to another in the whole year. So during the time of autumnal equinox and winter season in the northern hemisphere, they experience darkness for around 6 months in the North Pole and other places for different times at different latitudes. During the summer, that is June, there is a totally different phenomena that occurs at the Arctic Circle. The conditions are totally reversed and daylight increases as one goes polewards. The sun never sets at midsummer 21st June at the Arctic Circle, and there is a whole 24-hour period of continuous daylight. The region north of the Arctic Circle is generally known as the land of the midnight sun during summer seasons. Norway is known as the land of the midnight sun. It is an interesting phenomenon that there will be a 6 months of continuous daylight at the North Pole. Our Earth's shape is geoid, so the location of a place on the Earth can be mentioned with the help of latitudes and longitudes. Imaginary lines of the Earth can be divided into two types: latitude and longitude. So all the lines that we see on the globe that are horizontal are called latitudes, and the vertical one are called longitudes. Latitude, let's talk about it first. The angular distance of any point on the Earth's surface is known as latitude. It is measured in degrees from the center of the Earth. At the poles, our Earth is slightly flattened, hence the linear distance of a degree of latitude at the pole is slightly longer than that of at the equator. If joining all the places having same latitude by a line or a smooth curve, this produced line will be parallel to the equator and having an angle of 0 degree, and they are counted up to 90 degree north and south, the two poles. The lines of latitude are known as parallels. Some important latitudes: Antarctic Circle at 66.5 degree south of the equator, Arctic Circle at 66.5 degree north of the equator, Tropic of Cancer 23.5 degree north in the northern hemisphere, and Tropic of Capricorn 23.5 degree south in the southern hemisphere. So these are the imaginary lines and latitudes, and let's talk more on this. Latitudinal heat zones. Now, because of the revolution and tiltness of the Earth, at different latitudes we experience different type of temperatures on a same day or in the same particular season. So let's talk about that as well. So here we can see the latitudinal heat zones that is divided on the Earth according to the latitudes. Torrid zone that you can see at the center around equator. In all latitudes which are present in between the region of the Tropic of Cancer and the Tropic of Capricorn, here the midday sun is exactly overhead at least once a year. Hence this region receives the maximum heat, and this is called the torrid zone. When we talk about the climate, this region is also called as the tropical zone or tropical climate zone. Then comes the temperate zone. So above 23.5 degree north and below 23.5 degrees south. That means above Tropic of Cancer and below Tropic of Capricorn, and up to 66.5 degree north and south. The region that particularly exists is called a temperate region. So on any latitude beyond the Tropic of Cancer and Tropic of Capricorn, here the midday sun never shines overhead. Midday sun is the phenomena when the sun is just above the head, and this situation occurs only in the torrid zone. Towards the pole, the angle of the sun rays goes on decreasing. Due to this reason, the area beyond bounded by the Tropic of Capricorn and the Antarctic Circle in the southern hemisphere, and the Tropic of Cancer and the Arctic Circle in the northern hemisphere have moderate temperatures. These are called temperate zones. Then comes the frigid zone. These zones are very cold, lying between the Arctic Circle and the North Pole. That means 66.5 degree north to 90 degree north in the northern hemisphere, and the area of the Antarctic Circle and the South Pole in the southern hemisphere. That means 66.5 degrees south to 90 degrees south. Because at the horizon the sun does not rise much above, so its rays are always slanting. These are called frigid zones. Then comes the longitude. It is an angular distance of a pole measured in degrees along with the equator, Earth east or west of the prime meridian. When observing the globe, the longitudinal lines are shown as a series of semicircles which pass through pole to pole and cut through the equator. Such lines are known as longitudinal lines. Prime meridian, it is 0 degree longitude that runs through Greenwich near London, where the British Royal Observatory is situated. The British Royal Observatory has a very important function that determines local time in relation to GMT, or Greenwich Mean Time, which is sometimes referred to as world time. Meridians are separated by 1 degree of longitude at the equator, which is about 111.32 kilometer apart between two meridians. And similar is the situation for latitudes as well. The distance between two latitudes is 111 kilometer. Meridians are those lines joining all places that are situated at the same longitude. So longitudes, I hope you are able to understand, are the vertical lines. Greenwich meridian separates the earth into two hemispheres once again. One is the east and one is the west, and according to that the time is calculated. Here you can see this is the longitudes and latitudes diagram on the map. So local time. In one day or 24 hours, the Earth makes its one complete revolution of 360 degrees and crosses through 15 degree in 1 hour, or 1 degree in 4 minutes. So if you take the number of longitudes, that is equal to 360, and we do some particular calculations in mathematics with the relation to the 24 hours, that is the rotation time, we will get the answer that 1 degree, the Earth rotates 1 degree in just 4 minutes. As we know that Earth rotates from west to east on its own axis, so when we go every 15 degree eastwards, local time advances by 1 hour. On the contrary, when we go westwards, local time is retarded by 1 hour. For example, at prime meridian, if there is 100 noon, it will be 2 p.m. in all places on the 15 degree east longitude, while 12 p.m. in all places on the 15 degree west longitude. I hope this point is really clear, that 15 degree is the mark that determines 1 hour of distance. And according to the 0 degree Greenwich meridian, if there is 12 noon, it is on 0 degree Greenwich meridian. Then 50 degree east, it will be 1 p.m. and 15 degree west, it will be 11 a.m. Now standard time. So there would be much difference in local time between one town and other if each town were to keep the time of its own meridian. A system of standard time is observed by all countries to avoid all these problems. Standard time is the uniform time which is fixed by each country with the relation to the mean time of a central meridian or the meridian which is chosen in such a way that on which the most important city is located. It would be inconvenient to have a single time zone in larger countries such as Canada, USA, China, and USSR. So these countries have multiple time zones. This central meridian is divisible by 7.5 degree. Hence, the standard time differs from GMT in multiples of 30 minutes. As India has the meridian that is 82.5 degree east, and according to that, the standard time of India is GMT plus 5:30. Let's talk about the Indian Standard Time. So the meridian of 82.5 degree east has been accepted by the Indian government as the standard time of India, which is ahead of Greenwich Mean Time by 5 hours and 30 minutes. This meridian passes through Naini, Allahabad, closer to Mirzapur. The international date line. Here you can see the international date line that also passes through the Pacific Ocean. It is the 180 degree longitude and it defines the date line. The countries that are towards the west and towards the east, they particularly have different dates according to this line. To avoid the confusion of the difference of one day while traveling across the world by people, the concept of the international date line has been produced. It correlates with the 180 degree east or west meridian of longitude. It falls on the opposite side of the Greenwich meridian as this line is crossed, so the date changes by 1 day or 24 hours. The date to the east of it is 1 day ahead than to its west when it has been counted from the prime meridian. If we travel westwards of prime meridian up to 180 degree west, we have to put our watch back by 12 hours, and while traveling eastwards up to 180 degree east, have to put our watch 12 hours forward. The international date line in the mid-Pacific curves from the normal 180 degree meridian at the Bering Strait, Fiji, Tonga, and other islands to prevent confusion of day and date in some of the island groups that are cut through by the meridian because they belongs to the territories of different countries. And that's it in this session. I hope you learned a lot of things related to world geography with the introduction and other things. I will meet you in the next session. Till then, bye bye and thank you.